Hello students, welcome back to Rajur Academy. In the previous session, we solved model question paper problems and some important concepts also. But in this session, we are going to solve the previous semester question paper, December exam 2025. There are three problems in model 1, question number 1B, question number 2B and 2C. Similarly, in model 2, there are two problems, question number 3C and question number 4B. Then in model 3, here also two problems, question number C and question number 6B. Let's solve all these problems in this session. This will definitely helpful to your upcoming semester examination. If you have any suggestions or any doubts, comment it in comment box and like this session for your examination purpose. ಅದೇ ರೀತಿ ಇನ್ನೂ ಯಾರು ನಮ್ಮ ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿಲ್ಲ, ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ. ನೆಕ್ಸ್ಟ್ ಸೆಷನಲ್ಲಿ ಜುಲೈ 24 ಕೂಡ ನಾವು ಕ್ವಶನ್ ಪೇಪರ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಲೆಟ್ಸ್ ಸಾಲ್ವ್ ಆಲ್ ದೀಸ್ ಕ್ವಶನ್ಸ್.
Rajur Academy. Grow with knowledge.
Question number 1B. Differential manometer is connected at 2 points A and B of two pipes. The center of pipe A is 3 meter above center of pipe B. Pipe A contains liquid of specific gravity 1.5 while pipe B contains a liquid of specific gravity 0.9. The manometric liquid mercury is 5 meter below the center of pipe A. The pressure at A and B are 1 kg of per centimeter square and 1.8 kg of per centimeter square respectively. Find the difference in mercury level in the differential manometer. First of all, we have to write the diagram for this problem. This is the diagram. There are 2 points, point A and point B. The center of pipe A is 3 meter above center of pipe B. This is center of pipe B and this is center of pipe A. The difference is 3 meter. Pipe A contains liquid of specific gravity 1.5, that's okay, while pipe B contains liquid of okay and specific gravity 0.9. Then the manometric liquid mercury, this is manometric liquid mercury is 5 meter below the center of pipe. This is the center of pipe A. ಇಲ್ಲಿಂದ ಪಾಯಿಂಟ್ ಬಿ ಗೆ 3 ಮೀಟರ್ ಇದೆ ಆಲ್ರೆಡಿ, ಇಲ್ಲಿಂದ 2 ಮೀಟರ್, ಟೋಟಲ್ 5 ಮೀಟರ್. ಓಕೆ, ಪ್ರೆಷರ್ ಇನ್ ಪಾಯಿಂಟ್ ಎ ಈಸ್ 1 kg of per centimeter square. Pressure at B is 1.8 kg of per centimeter square. The given data are specific gravity of liquid at A is 1.5. If we multiply this to 1000, then it will become a density of the liquid 1500. Specific gravity of liquid at B is 0.9 multiplied by 1000, that will the density is 900. Pressure at A, PA is equal to 1 kg of per centimeter square ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದನ್ನ ನಾವು ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಕ್ಕೆ for centimeter square we will multiply 10⁴. Then for kg of we will multiply 9.81 Newton because 1 kg of equal to 9.81 newtons. After solving, we will get pressure at A is equal to 10⁴ into 9.81 Newton per meter square. Similarly, the pressure at B given is 1.8. So after conversion, we will get a 1.8 into 10⁴ into 9.8 Newton per meter square. Density of mercury is 13.6 into 10⁵ kg per cubic meter. Let's consider x-axis is a datum line. Therefore, the pressure above x-axis in the left limb, that means pressure in the right tube, that is given by the pressure in the left side, that is equal to density of mercury, that is rho m into G into H. This is for mercury, plus then there is a liquid. For that, density of A into Z into H plus pressure at point A. So you can observe here the density of mercury is 13.6 into 1000, then G is 9.81, H as it is because we don't know the value of height. Next, density of A is 1500, we already calculated in the first step. Z is similar 9.81, height is 2 plus 3, from here 2 plus 3 total 5. Then the pressure at A PA is 9.81 into 10 raised to 4. This is the first one. Second one is the pressure above bottom line in the right side. The formula is same, rho Z H. This is density of liquid in point B. This is G and this is height. That means from here to here is 2, then here to here is H. So H plus 2. Then the pressure at B is 1.8 into 10 raised to 4 into 9.81, which is already calculated in step 1. Equating the pressures at A and B, we will get 13.6 into 1000 into 9.81 H plus 7500 into 9.81 plus 9.81 into 10 raised to 4. That is pressure in a right side. That's equal to 900 into 9.81 into H plus 2 plus 1.8 into 10 raised to 4 into 9.81. This is in the right side. Dividing these equations by 1000 into 9.81 for a simplification purpose, we will get 13.6 H plus 7.5 plus 10. That is equal to H plus 2 into 0.9 plus 18. Now the value of H is equal to 2.3 divided by 12.7, that is equal to 0.181 meter. In terms of centimeter, that will become 18.1 centimeter. This is the difference in a mercury level in the differential manometer. ಯಾವ ಸ್ಟೆಪ್ ಅರ್ಥ ಆಗಿಲ್ಲ ಕಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಕಮೆಂಟ್ ಮಾಡಿ, ನಾನು ಸಾಲ್ವ್ ಮಾಡ್ತೇನೆ. So next, go to the second question. What is the bulk modulus of elasticity of a liquid which is compressed in a cylinder from a volume of 0.0125 cubic meter at 80 Newton per centimeter square, pressure to a volume of 0.0124 cubic meter at 150 Newton per centimeter square pressure? This is a very easy and a simple question. Remember the formula for bulk modulus. K is equal to difference in pressure divided by difference in volume with respect to original volume. The given data is initial volume V is equal to 0.0125 cubic meter. Then final volume is 0.0124 cubic meter. Change in volume, this is equal to initial volume minus final volume. We will get a 0.0001 cubic meter. In the bulk modulus formula, we required change in volume with respect to original volume. Therefore, dV divided by V, that is equal to 0.0001 cubic meter divided by original volume 0.0125. This minus represent decrease in a volume. Initial pressure, this is step 2. Step 2, initial pressure 80 Newton per centimeter square Final pressure is 150 Newton per centimeter square. Change in pressure dP is equal to final pressure minus initial pressure, that is equal to 70 Newton per centimeter square. We know that the formula for bulk modulus is equal to change in pressure 70 divided by dV divided by V, 0.001 divided by 0.0125. After solving, we will get K is equal to 8.75 into 10 raised to 3 Newton per centimeter square. This is your answer. If you solve these two steps, you will get a 6 marks. Okay. In this problem, you have any doubts? Comment it in a comment box. ಸೊ ಇದರಲ್ಲಿ ಡೌಟ್ಸ್ ಏನಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ನಿಮಗೆ ಎಕ್ಸಾಮ್ಗೆ ಯೂಸ್ ಆಗ್ತಿದೆ ಅಂತ ಅನಿಸಿದ್ರೆ ಈ ಸೆಷನ್ನ ಲೈಕ್ ಮಾಡಿ. ನಾವು ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ನ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಸಿ ಕ್ವಶನ್ ನಂಬರ್ 1 ಸಿ. An equilateral triangular plate of base is 5 meter. Then this is immersed in a water. Base at 2 meter and affix at 6 meter from the free surface of water. Calculate the total force and position of center of pressure. ಇದೇ ಥರ ಸಿಮಿಲರ್ ಪ್ರಾಬ್ಲಮ್ನ ಮಾಡೆಲ್ ಕ್ವಶನ್ ಪೇಪರ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ಆ ಸೆಷನ್ ಆಲ್ರೆಡಿ ಯಾರು ವಾಚ್ ಮಾಡಿದ್ದೀರಾ ಅವರಿಗೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಈಸಿ ಆಗುತ್ತೆ, ನೀವೇ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. ಯಾರೆಲ್ಲ ವಾಚ್ ಮಾಡಿಲ್ಲ ಆ ಪ್ರಾಬ್ಲಮ್ನ ವಾಚ್ ಮಾಡಿ. ನಾವು we will solve this question. The given data is the side length of the equilateral triangle is 5 meter. The base of the plate at depth of 2 meter. Therefore, h base is equal to 2 meter. The affix of the plate is at a depth of 6 meter. That is, h affix is equal to 6 meter. Then density of the water is 1000 kg per meter cube. Then G acceleration due to gravity is 9.81 meter per second square. The formula required to solve this problem is height of an equilateral triangle, h is equal to square root 3 divided by 2 into side of the triangle. S is side of triangle. The center of a triangle is located at 1/3 of the height from the base. We know that. The moment of inertia of a triangle about its centroid axis Iz is equal to bh cube divided by 36. ಇದು ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡೋಕ್ಕೆ. ದೀಸ್ ಟು ಇಕ್ವೇಷನ್ಸ್ ನಿಮಗೆ ಗೊತ್ತಿದ್ರೆ ಈಸಿಯಾಗಿ ಈ ಪ್ರಾಬ್ಲಮ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. ಸ್ಟೆಪ್ 1 is calculate the height and area of the triangle. ಸೊ ಹೈಟ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಜಸ್ಟ್ ಇವಾಗ ತಾನೇ ಹೇಳಿದ್ರೆ h is equal to root 3 divided by 2 into side of the triangle. Side 5 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. That is equal to 4.33 meter. From height, we can calculate the area of the triangle. A is equal to half into base into height. Half into base is 5 meter and height is 4.33. That's equal to 10.825 meter square. Step 2, determine the depth of the centroid. So centroid is located at 1/3 of the height from the base. Therefore, depth of centroid, h centroid equals to h base, height of the base, plus 1/3 of the height of the triangle. So height of the base is 2 meter plus 1/3 into 4.33 meter. That's equal to 3.443 meter. This h base 2 meter ಎಲ್ಲಿಂದ ಬಂತಂದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟಾರೆ ನೋಡಿ 2 meter. This is height of the base from the free surface of water. Calculate the total hydrostatic force. Total force, this is total hydrostatic force. F is equal to rho z a h centroid. This is equal to rho is 1000 into z is 9.81 multiplied by area is 10.825. That is multiplied by h centroid. Just in the previous step we calculated 3.443. After solving this equation, we will get a 365,300 Newton. That is equal to 365.3 kilo Newton. Now, the position of center of pressure, that is given by HCP is equal to H centroid plus Iz divided by area into H centroid. We have to calculate moment of inertia. Iz is equal to 5 into 4.33 divided by 36. This is equal to 11.25 meter raised to 4. In the first step, we discussed Iz is equal to base into height cube divided by 36. Okay. After substituting 11.25, we will get a 3.745 meter. In this model, we solved total 3 problems. I hope this concept is clear for you. ಇನ್ನೂ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದ್ದರೆ ಕಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಮೆಂಟ್ ಮಾಡಿ ಮಾಡೆಲ್ 2 ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಸಾಲ್ವ್ ಮಾಡೋಣ. Model 2, question number 3C. In a three-dimensional incompressible flow, the fluid velocity components are given by u is equal to x minus 4y and v is equal to minus y minus 4x. Show that velocity potential exists or not. Actually 6 marks problem alla idu, but 6 marks ಕೊಟ್ಟಿದ್ದಾರೆ. So every step will carry a 2 marks. Here the given data are u is equal to x minus 4y and v is equal to minus y 4x. Partial differentiation dou u by dou x, we will get a 1. Dou u by dou x, that is equal to 1 minus 0 ಬರುತ್ತೆ. So dou u by dou x is equal to 1. Similarly, dou v by dou y, for this equation we will get a minus 1. 4x becomes 0. Dou u by dou x plus dou v by dou y, that is equal to 1 minus 1, that is equal to 0. That means dou u by dou x plus dou v by dou y, that is equal to 0 ಬಂದ್ರೆ velocity potential exists. Otherwise there is no velocity potential. Therefore in the given data, dou v by dou x is 1 and dou v by dou y is minus 1. Therefore dou u by dou x plus dou v by dou y, that is equal to 0. Hence flow is continuous and velocity potential is exist. ಇಷ್ಟು ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ 6 marks ಬರುತ್ತೆ. 2 marks, 2 marks and 2 marks. Question number 4B. Once read this question. The given data are the diameter at A is 20 centimeter, diameter at B is 50 centimeter, the pressure at A is 80 kilonewton per meter square and B is 60 kilonewton per meter square. The end B is 3 meter higher than A. That means ZA is equal to 0. Therefore ZB minus ZA is equal to 3 meter. ZA means initial level of point A. That's it. So if we consider it, point A is here and point B is here, this is 0, this is ZA, that is equal to 0, and this is ZB, that is equal to 3 meter height. The flow rate is given and discharge Q is equal to 200 liter per second. From Bernoulli's equation you can solve this problem. So Bernoulli's equation for head loss, PA divided by rho z plus VA square divided by 2z plus ZA, that is equal to PB divided by rho z plus VB square divided by 2z plus ZD plus head loss HL. Then we know that the density of water is 1000 and acceleration due to gravity Z is equal to 9.81. Using these data, we can solve this problem. Step 1. Converts the diameters in a meter. Centimeter ಕೊಟ್ಟಿದ್ದಾರೆ, so ಅವನ್ನೆಲ್ಲ ಮೀಟರ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿ. Calculate cross sectional areas. Area at A is equal to pi d square by 4 and area at B is equal to pi d square by 4. After substituting dA and dB, we will get a area at A is equal to 0.0314 meter square and area at B is equal to 0.1963 meter square. By using the continuity equation, VA is equal to Q is 0.2 cubic meter per second divided by area at A is equal to 0.0314, VA is equal to 6.37 meter per second. VA andre velocity at A. Then the velocity at B is equal to Q is 0.2 divided by area at B is equal to 0.1963. That is equal to 1.02 meter per second. Velocity at B is equal to 1.02 meter per second. Now we have to calculate total head at A and B. We already know that ZA is an initial point, therefore Z is equal to 0, and point B is 3 meter height from point A. Therefore total head is equal to P divided by rho Z plus V square divided by 2Z plus Z. After substituting all these values, we will get head at A is equal to 10.223 meter. Simple. The pressure at A is 80 kilonewton per meter square. Rho is 1000 and Z is 9.81 plus 6.37 meter per second whole square divided by 2 as it is. Z is 9.81, ZA is 0. So we will get HA is equal to 10.223 meter. Next, similarly, we can solve for total head at B, 9.169. Pressure at B is 60 kilonewton in the given data, divided by rho is 1000, Z is 9.81, and velocity is 1.02 meter per second. Then ZB is 3 meter. Therefore, we will get HB is equal to 9.169 meter. Since HA, head at A is greater than head at B, the flow occurs from A to B. This is answer for first question. Direction of flow occurs from A to B. Then second question, head loss between A and B. That means difference in total heads. Therefore, HL is equal to 10.223 meter minus 9.169 meter. We will get a 1.054 meter. Similarly, model question paper allo kuda ನಾವು ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೇವೆ. ಅದನ್ನು ಕೂಡ ವಾಚ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಎಕ್ಸಾಮ್ ಗೆ ಹೆಲ್ಪ್ಫುಲ್ ಆಗುತ್ತೆ. ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಲಿಂಕ್ ಹಾಕಿರ್ತೀನಿ, ಹೋಗ್ಬಿಟ್ಟು ನೀವು ವಾಚ್ ಮಾಡಬಹುದು. Module 3, question number 5C. This is the given data. For this question, the given data are pipe dia is 0.5 meter, pipe length is 100 meter, Q discharge that's equal to 0.5 cubic meter per second. Then sonic velocity is 1430 meter per second. We know that density of water is 1000. To solve this question, the area is equal to pi by 4 into d square. D is 0.5 meter. Therefore, area is equal to 0.1963 meter square. Velocity V is equal to discharge by area. Discharge is 0.5 cubic meter per second. That's divided by 0.1963. We will get a 2.547 meter per second. Change in pressure is given by density of the water, sonic velocity, and actual velocity of the water. Therefore, change in pressure that's equal to density of water is 1000, sonic velocity is given in a question 1430 meter per second. Then the actual velocity just we calculated 2.547. After solving, we will get change in pressure equals to 3649.2 kilopascal. This is for instantaneously closed valve. Next, second question is valve closed in 1 second. Change in pressure is equal to density into length is multiplied by velocity in a given time. Change in pressure in 1 second is equal to rho is 1000 then length is 100 meter, actual velocity is 2.547 divided by given time is 1 second. After solving, we will get a 254.7 kilopascal. This is the answer for second question. ಇಷ್ಟು ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ you will get a 8 marks. Next question number 6b. The given data for this question is the width of the rectangular weir is 1 meter and the depth over rectangular weir is 150 mm. The coefficient CD is given 0.62 for rectangular weir and CD is given for triangular weir is 0.59. To solve this problem, you have to know these formulas. First one, discharge is given by 2/3 into CD into B square root of 2Z h raised to 3/2. Here CD is coefficient of discharge, B is breadth and h is height. And discharge for triangular weir is given by Q is equal to 8/15 CD tan theta by 2 square root of 2Z into h raised to 5/2. This is for triangular weir and this is for rectangular weir. Depth over rectangular weir is given already in the question, 150 mm. So rectangular weir is equal to HR is equal to 0.15 meter. Discharge over rectangular weir formula already we know that. So after substituting all the values, that is 2/3 multiplied by coefficient of discharge for a rectangular weir is given 0.62. Then breadth is 1 meter into square root of 2 as it is into Z is 9.81, that's multiplied by height is 0.15 raised to 3/2. After solving, we will get QR is equal to 0.0565 cubic meter per second. This is the discharge over rectangular weir. In the next step, equation for discharge over rectangular weir. Theta is 90 degree because it's a right angled weir. Therefore, we know that equation for triangular equation is 8/15 CD square root of 2Z into h raised to 5/2. Qt is equal to 8/15. Coefficient of discharge is 0.59 given in a problem. That is multiplied by square root of 2 into Z into, we don't know this value. We already calculated discharge over rectangular weir, that is 0.0565. That's equal to discharge over triangular weir is 1.749 into h raised to 5/2. After solving for HT, we will get HT is equal to 0.167 meter. This is the depth over triangular weir. ಈ ಸೆಷನ್ ಮುಗಿತಾ ಬಂತು. ಹಂಗಾಗಿ Model 4 and Model 5 ನ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಅಲ್ಲಿ ನಾನು ಸಾಲ್ವ್ ಮಾಡ್ತೇನೆ. ಅಲ್ಲಿ ಕೂಡ 4 ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದಾವೆ. Model 4 ಅಲ್ಲಿ 2 ಪ್ರಾಬ್ಲಮ್, Model 5 ಅಲ್ಲಿ 2 ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದಾವೆ. ಅದನ್ನು ಕೂಡ ಈಸಿಯಾಗಿ ಯಾವ ಥರ ಸಾಲ್ವ್ ಮಾಡಬೇಕಂತ ನಾನು ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೇನೆ. ಈ ಸೆಷನ್ನ ಯಾರೆಲ್ಲ ನೋಡ್ತಾ ಇದ್ದೀರಾ ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ಲೈಕ್ ಮಾಡಿ, ಅದೇ ಥರ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಕೂಡ ಶೇರ್ ಮಾಡಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಅಪ್ಡೇಟ್ಸ್ ಬರಬೇಕಾದ್ರೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಬಟನ್ ಮುಂದೆ ಬೆಲ್ ಬಟನ್ ಇರುತ್ತೆ, ಅದನ್ನು ಪ್ರೆಸ್ ಮಾಡಿರಿ, ಸೊ ನಿಮಗೆ ನೋಟಿಫಿಕೇಶನ್ ಬರುತ್ತೆ. ಆಫ್ಟರ್ ಸಾಲ್ವಿಂಗ್ ದಿಸ್ ಕ್ವಶನ್ ಪೇಪರ್, we are going to solve the June-July 2024 question paper also. That will helpful for your fluid mechanics exam. ಇದಾದ್ಮೇಲೆ ನಿಮಗೆ ಇನ್ನೂ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದ್ದರೆ ಅಥವಾ ಏನಾದರೂ ಡಿಫಿಕಲ್ಟೀಸ್ ಅಂತ ಅನಿಸ್ತಿದ್ರೆ ಕಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಮೆಂಟ್ ಮಾಡಿ, ನಾನು ನಿಮಗೆ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ ಒಳಗೆ ಅದನ್ನು ಕೂಡ ಸಾಲ್ವ್ ಮಾಡ್ತೇನೆ. ಥ್ಯಾಂಕ್ ಯು. ವಿ ವಿಲ್ ಸಿ ಯು ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್.